Okay, so I'm start. Okay, so I'm starting the class now. Those who have to join will join. Okay, so in the last class we were going through this fifth lecture, and we had learned about Python tutor, that how to visualize your code in Python tutor, how to execute it line by line and see what's happening. Okay, we saw that in the previous lecture. Now in this lecture, uh, we will continue the last lecture and start with namespaces. Okay, my voice is audible to everyone, and my screen is visible. Akhil and Pragya. Okay. Okay. So, as the name suggests, a namespace is a space that holds the name. Okay. So, whenever you create a variable, that variable is like a name only that is storing some value, and that variable name is stored in a space that is called a namespace. Okay. It holds the namespace. It holds all the names. Okay. It's just like that only. Okay, nothing complex. A namespace defines a mapping of names to the associated objects. Okay, it is the place where all the variables you have created and all the values that is associated with those variables, that all those things are held in that namespace only. Okay, you can imagine it like it's kind of an imaginary thing only. There is no like physical space or anything where it holds it. Okay. In Python, a module, class, or function defines a namespace. Names that appear in the global frame are called the global names, and collectively, Shanchi Mishra. Yes, Shanchi Mishra, are you there?
Yes,
Your voice is not clear. It's very okay. Turn off your mic. Okay, Shanchi Mishra, turn off your mic. It's creating noise. Okay. So names that appear in the global frame are called the global names. What is meant by global frame? It is outside the definition of classes, functions, and objects. Okay. So these are called global names that are defined in the global frame are called the global names, and collectively they define the namespace called the global namespace. Okay, the names introduced in a class or function are said to be local to it. The region is in a script in which a name is accessible is called its scope. Thus, the scope of a name is resolved in the context of a namespace in which it is defined. Okay, so a lot of English. I'll explain it. So, what is global frame? Global frame is the region where everything is defined. All the functions, all the variables, all the classes. Okay. The place where it is defined, the region where it is defined is called the global frame. Okay. In the global frame only we write all the codes only. Okay. So that is the global frame or global namespace. Okay. And those variables that are defined inside a function or inside a class, okay, those variables are called the local variables or local variables of that specific function or class. Okay, so global means if it is defined in the global space, if the variable is outside all the class and function outside it, then it is called the global name. And if a variable is defined inside a class or inside a function, that is called a local, that is called local names. Local, either local namespace, that region will be called, or the variable will be called a local variable. Okay, the region in a script in which a name is a name is accessible is called its scope. Means the region, either the global region or the local region, the region in which a variable is accessible, that is called is a scope. Scope means the region in scope tells us the region where a variable will be accessible. So there will be regions in which a variable might not be accessible. For example, if there is a variable that you have defined in inside a function, If you try to access that variable outside that function, so that variable will not be accessible. Okay, so that variable will not be accessible outside a function. So that space where it is accessible, that variable is accessible, is called its scope. So everything will be more clear when I'll give examples. Okay, I'm just going through the these lines only. I'll explain everything with examples, then it will be more clear. Okay. Thus, the scope of a name is resolved in the context of the namespace in which it is defined. That's it. So here is an example. We'll see this example. For example, for each of the functions f1 and f2 defined in a script may have the name x. The variable x defined in function n1 f1 may refer to an object of type different from that of the object associated with variable x in the function f2. A namespace maps names to the objects. Being an object-oriented language, definition of functions and classes are all the examples of object. Okay, so let's do this. First of all, let's clear it, and we will define two functions. I'll define f1. I'll write x is equals to 2, and I will return x. Okay, and I'll define another function f2, and here also I'll define x, but I'll give it a different value. It's a 3, and here also I will return x. Okay, so if I will call f1, what will I get? If I'll call f1, I'll get 2. Why I'm getting 2? Because inside f1 the variable that is defined x, which is defined, it has the value 2 and we are returning x. That is why we are getting 2. But if we run f2, if we run f2, we are getting 3 now. Why? Because inside f2 this variable x, although it has the same name as this variable, it has different value, which is 3, and then we are returning x, so we are getting 3. So you can say that no matter how many times I run f1 and f2, I'll always get the same results. I'll always get the same. Okay, for f1 and f2, I'll always get the same results. If I run f1, if I execute f1, then I'll get 2, and if I execute f2, I'll get 3. Why? Because these although these two variables in f1 and f2 may have the same name, but actually they are different. Okay, it's like a person, it's like two students in a class having the same name. Okay, so they may have the same name, they may have the same first name and the last name also, but they are two different people, they are two different person. Okay, they are two different persons, just like that only. This x is equals to x is equals to 3, they have the same name, but they are two different variables because they are defined inside different functions. Okay, so this is what is being explained here. All right, now we will understand what is the scope. The scope rules for a name in Python are often summarized as the LEGB rule. So there is a rule in Python called LEGB rule. What does this rule stands for? LEGB stands for local, enclosing, global, and built-in. Okay, the full form of L is local, E for enclosing, G for global, and B for built-in. Okay, all names are defined within the body of a function are local to it. So yeah, this line I've already explained. If you define a variable inside a function, that variable is local to that function only and cannot be accessed outside that function. All right, so function parameters are also considered local. Okay, the parameters of a function are also considered local only. If a name is not locally found, Python recursively searches for its definition in an enclosing scope. So I'll explain with an example. Let's see. So I'll define a function. Okay, let's use these functions only. Pragya, Are you there? Okay, your voice is not audible. Can you write in the chat box? Okay. Pragya, your voice is not audible. You write in the chat box. I don't know why everyone has left. I mean, is my voice not clear or what? It's the reason everybody is leaving. Earlier, they used to join for hours. I used to take the class for hour or 2 hour. They used to join the class, and now they are like, it's like they are not interested anymore in learning. Pragya, you are also not responding. If this is the case, I will leave the class and okay. Yeah, you are in, but everybody else is out, and I don't know why. Let's see. I'll continue the class. You are understanding now whatever I'm explaining, Pragya? That is clear to you, or if there is any doubt, you may ask. Maybe I was explaining and they weren't able to understand, and I also didn't ask if you are understanding or not. So maybe they left. If only they had told me, ki, okay, sir, I'm not getting it, I'll explain it. I'll try to, I would have tried to explain it more clearly with more examples. Pragya, are you understanding or not? If you are also not understanding, there is no point in continuing further. I'll explain first of all everything that you are not getting, and then I'll move forward only. Yes, Pragya, I'm waiting. If you are, I'll wait for 1 minute for your response, and then I'll leave. If nobody else is also there, so there is no point in continuing. Okay, you are understanding? Okay, good. Just tell me, write in message or open your mic and tell if there is any part you are not understanding, and I'll explain it only. Okay. So LEGB rule. Okay. So LEGB stands for local, enclosing, global, and built-in. All names defined within the body of a function are local to it. Okay. The example I was giving. Okay. So that Sapna, are you there? Sapna,
Yes, sir.
why have you joined so late?
Sir, I was waiting for the message, but it was 10 minutes late, so I thought that there will be no class today. Sorry, sir.
But it was 10 minutes late, but it was the message to join the class only. But anyways, leave it. Okay, so this is the function, and I've defined a variable x is equals to 2 inside this function. Okay, now what I will do, I will try to access this variable outside this function. I'll write print x. Okay, I'll write print x. Now let's see what I will get. I will run this, and I'm getting this error. Name x is not defined. Why? Because this variable x is not defined in the global frame or the global namespace or the global region. Okay, this variable is not defined in the global frame. That is why Python is not able to access it, and that is why it is giving this error, because Python cannot access a variable, global variable, inside a function. from a local region it cannot access it. Only if I had written this print x inside the function, then it would have easily done it. And it, yeah. Now if I do this, if I call f1, now it can print x, that is 2. But if the same thing I will do outside, if I'll try to do it again outside the function, I'll get the name error. Why? Because this variable x is not defined outside this function. So there is no x in the global frame. That is why Python is not able to access it. That is why it is giving an error. All right. All right. Okay. So this this was the, yeah. So this is what this line is saying. If name is not locally found, Python recursively searches for its definition in the enclosing list. Okay, so this is a different thing. Okay, okay. So let's understand what this LEGB rule means. LEGB rule stands for local, enclosing, global, and built-in. So this means that whenever Python tries to access a variable, it first of all checks that variable in the local frame or local region. Then it checks for it in the enclosing region. Then it checks for it in the global region, and then it checks for it in the built-in region. Okay. So, okay. So I'll create another example for you to understand. Let's create this function uh, f, okay, or f1 only again. I'll create this function f1, and inside this function I'll create a variable x is equals to 2, and then I will return x. Okay, and I will also, what I will do, I'll create another variable x is equals to 2 outside, x is equals to 3 outside this function, and instead of returning x, I will actually print x. Print x. Okay. So now I will call the function f1. I will call the function f1, and if I run it, what will happen? You will get x is equals to 2. Why? Because when I run f1, it is going inside this function. It is declaring that the variable local variable x is equals to 2, and then it is printing x. So when it prints x, so there are two values for x. So this is 2 and this is 3. But Python has printed this 2. Why? Because this of this LEGB rule, because of this LEGB rule, Python first of all searches for a variable in the local region or local space. Okay, so the local space is this function only. Inside this function, we have this variable x. So we are printing x from inside this function. So the region inside the function is the local region. So the Python will search for it, for this variable x in this local region only. So while searching for it, it found that this variable x is present in the local region and it has value 2. So I will print 2. Okay. So Python first of all searched for this variable x in the local region. It found it and it printed it. But if I remove this x from the here, if I do this now, if I commented this part, okay, now this part is no more executing. Okay. So now if I run this function f1 again, I'm getting, okay, now I'm getting 3. Why I'm getting 3? Because of this, again, this LEGB role only. Because Python searched for it first of all in the local region. It couldn't find in the local region. Then it searched for it in the enclosing region. It also couldn't find it in the enclosing region because there is actually no enclosing region right now. I'll explain what is the enclosing region, but understand that there is no enclosing region right now, so Python cannot search for it in there. And then it will search for it in the global region. So in the global region, we have x is equals to 3. So the Python found that in the global region, this variable x is there, so I can access it from there and print it. So it accessed this variable x from this global region and printed the value 3. Okay. So I'll do this again. First of all, when I do this, I'm getting 2. But if I comment this now, now if I run F1 and after commenting this, and if I run this, I'll get 3. So for the same function, I'm getting two different return values, because in one case, this variable x is equals to 2 was present inside the function, and in the another case, this variable x is equals to 2 was not present, and it accessed this variable x is equals to 3 from the global region and printed it. All right, all right. It is it clear to Pragya and Sapna? There is any doubt you may ask, or I'll move forward. All right. If a name is not locally found, Python recursively searches for its definition in the enclosing scope. Okay, now we will see what is an enclosing scope. So for enclosing scope, we have to get two different functions. I'll define function f1, and I'll write x is equals to 1, and then I'll define this function f2, and write x is equals to 2, and here inside this function f2 I will print x. Okay, and now what I will do, also I will define the also I will define a variable x is equals to 3 outside this, and now I will call the function f1. When I call the function f1, so first of all, the variable x is equal to 3 we defined, then function f1 is defined. Inside this function f1, we have variable x is equal to 1. Inside this function f1, we created another function f2, and inside this function f2, we again created a variable with the same name x is equal to 2, and we are printing this x inside this function f2 from inside this function f2. So now when I call f1, okay, and to execute f2, I have to also call f2 from x1. Okay, okay. So when I run this code, what is happening? I'm getting 2. Why? See, first of all, this line is getting executed, x is equals to 3. Then this function f1 is getting executed, and whatever is inside this function is getting executed. Is getting So when I call this f1, this whatever is inside this function is getting executed. So first of all, the variable x is equal to 1 is defined, then this function f2 is defined. Inside this function, x is equal to 2 is defined, and x is getting printed. So when I from inside the function f1, so when I executed f1, it will go inside this function and come here. When it comes here, it will execute the function f2. So when it executes the function f2, what will happen? X variable x is equal to 2 gets defined, and it prints x, that is 2. So that is why I'm getting 2 here, because again, because of the LEGV rule, Python is searching for the variable x, this variable x in the local region. What is the local region of this function? The local of this region is this function is this space where all the components of this function are written. Okay, or whatever is written inside this function f2 is the region of this function only. That is the local region to this function. So it found, when it tried to print x, it found this variable x inside this function, okay, in the local region only. So in the local region it found it, and it printed x is equals to 2. Okay, now what is happening? Now if I comment this part, I will comment this part. Now if I comment this part and run this again, now see what is happening. I'll uncomment this, run this, pull the function f1, run this. So I'm getting 2 now. Now what I'm doing, I'm commenting this part and running the function f1 again. So you can see now, if I'll call the f1 again, and I'll run it. Okay, I have to run this also. After commenting, I have to run this part also. So I've ran it. and I'll run this part again. Now this time when I commented this part x is equals to 2, I am getting 1. Why? Because when it tried to print x, is first of all searched for the variable x in the local region, that is in this region. In this region it couldn't find the variable x. Okay, so in the local region it couldn't find the variable x. So after this what will happen, it will follow the LEGB rule. So it searched for the variable x in the local region, it couldn't find it. So after this it will search for it in the enclosing region. What is enclosing region? Enclosing region is this part. Enclosing region is the part where which is inside the function f1 but outside the function f2. So this part is the enclosing part. This part is the enclosing part where which is inside the function f1 but outside the function f2. So when it tried to print x, it couldn't find the variable x in the local region because this part is commented. So it went to the enclosing region. It tried to access s, tried to find x, and it found that x is present in the enclosing region and its value is 1. So because its value is 1, when I print x, I'm getting 1. Okay. Now what I will do, I will comment this part also. I will comment this x is equals to 1 also. Now when I commented x is equals to 1, I'm running f1 again. I'm running f1 again. Now if I run this again, this time I'm getting 3. Why I'm getting 3? Because when I tried to print x by using LGB rule, it first of all searched for the variable x in the local region. In the local region, there is no variable x because it is commented. So recursively, Harshvardhan, Harshvardhan, are you there?
Yes.
Yes, why have you joined so late? Hmm, it's almost
मुझे आइडिया
45
नहीं था
minutes
किस
since
चीज़
I
की मीटिंग
start
है।
the class. Yeah,
एक्चुअली मुझे आइडिया नहीं था किस चीज़ की मीटिंग है।
तुमने ग्रुप ज्वाइन किया है और तुम्हें आइडिया नहीं था किस चीज़ की मीटिंग है। चलो कोई नहीं, छोड़ो, जस्ट अ मिनट। हेलो, पहुंच गई? अच्छा अच्छा, चलो ठीक है, हम क्लास ले रहे हैं, ठीक है। हेलो, ठीक है, घर पहुंच के मैसेज कर देना। ठीक है, बाय बाय। Yeah, so I was explaining this. So when I ran this f1 function again after commenting this part and this part, what is happening? It is trying to print x. So when it is trying to print x, it is first of all trying to access the variable x. So first of all, it will, because of by using this LEGB rule, it will first of all access the variable x in the local region. So in the local region, we can see that there is no variable x because it is commented. So again, by using the LGB rule, it will now go and check in the enclosing region. What is the enclosing region? It is the region inside the function f1 but outside the function f2. So in the enclosing region also, this in this region there is no x present because it is commented. So Python also couldn't find the variable x in the enclosing region. So again, by using LGB rule, it will check in the global region. It will check in the global region, and in the global region, it will find that x, the value of x is equals to 3. So now after checking in the global, enclosed and local region, it couldn't find in the local and enclosed region, but it has found the variable x in the global region. So since it has found in the global region, it will simply print the value, access that value and print it. So that is why after commenting this part and this part, from the global region it accessed the value of x is equals to 3 and printed 3 now. Okay. Okay, Pragya and Sapna, you got it? The LGB rule. Okay, okay. So this is what LGB rule is. Also, there is last thing, built-in. What is built-in? Built-in are the variables or the functions or functions names that are already there in the Python, already built in there. For example, okay, okay. So let's do another thing. Now I'll replace this variable x with pi, and this variable x with pi again, and this one again with pi, and then I will write before this I will write this from math import pi. Okay, now see what I have done. From math I have imported pi. What is pi? Pi is the that value, that 3.14 value only. So if I run this, you can see that from math I have imported pi and I have printed pi, and this pi value is 3.14. This. Okay. So this is the pi. Okay. So this variable pi is there this variable pi is built-in variable. Okay, because it is already there. We have not declared this variable yet. Okay, we have only called it. This variable pi is already present in the math module, and we have accessed it from there only. Okay, now what I have done, now here I have again created another variable pi and its value is 3. Now I've created the function f1. Inside the function f1 I've again created a variable pi whose value is 1. After this I've inside this function f1 I've created another function f2, and inside this function f2 I've created another variable pi whose value is 2, and here after this I'm printing pi now. Okay, now what I'm doing, I'm calling f1. Okay, if I will call f1, I'm getting 3. Why I'm getting 3? Because when I called this f1, okay, f2, I called this f1, okay. Uh, I ran this, and when I ran f1, I'm getting 2 now. Why I'm getting 2? Because it is executing first of all the f1 function f1, and inside this function the variable pi is declared to 1. Then this function f2 is created, and after that function f2 is called. When this function f2 is called, pi is equals to 2 will get declared, and after that we are printing pi. That is why we are getting pi is equals to 2. That is why we are it is printing 2. Because of this LGB rule, it will first of all search it in the local region, and because it is searching in the local region, this pi, from this local region, it will find that the value of pi is equal to 2. That is why it is printing 2. Okay, now what I will do, I will comment this part, and I will call the function f1 again. When I call this function f1 again, okay, I have to execute this also, and when I call this f1 again, I am getting 1 now. This time I'm getting 1. Why? Because it is calling f1, it is going inside this f1, declaring pi is equals to 1. Then it is declaring the function f2. Then it is calling f2. Then when it is calling f2, it is trying to print pi. So it is, when it is trying to print pi, it is first of all searching for the value of pi in the local region. In the local region, there is no pi because it is commented. So because by using the LEGB rule, then it is searching for it in the enclosing region. Then it goes in the enclosing region. In the so this is the enclosing region. In the enclosing region, it found the value of pi is to be equals to 1. That is why print. So it accessed the value of pi to 1 and printed 1 from the enclosing region. Okay. Now I'll comment this part also and run this and call the function f1 again. Call the function f1 again. So this time when I call f1, I'm getting 3. Why I'm getting 3? Because On calling f1, is going inside the function f1, defining the function f2, and then calling f2. When it is calling f2, it is trying from this f2 we are printing pi. So it will first of all search for the pi in the local region. In the local region it cannot find pi because it is commented. So because by using the LEGB rule, it will then search for it in the enclosing region. In the enclosing region again the pi is commented, so there is no pi in the enclosing region. So it will go in the global region. So the third member of this LEGB rule is the global region. So the Python, after failing to find it in the local and enclosing region, it will try to find it in the global region. In the global region, we have declared pi is equals to 3. So there is a pi in the global region whose value is 3. So it will access it from here and print pi. That is why on calling the function f1 again, I am getting 3. Okay. Now I will comment this part also. I'll comment this part also, and I will call the function f1 again. We'll call the function f1 again. Okay, I'll run this, and this. Okay, so now this time I'm not getting 1, 2, or 3, but I'm getting 3.1459 and so. Why? Because when I try to access pi from inside the function f2, it will search for it in the local region, this region. So this in this region there is no pi. So it will, using the eligible rule, it will go in the enclosed region. This is the enclosed region. Inside the enclosed region again we do not have any pi because it is commented. So again using the eligible rule, it will go in the global region. In the global region again there is no pi because again it is commented. Then the fourth member of this eligible rule is built-in. So built-in region. So in the built-in part consists of all the variables that are defined, that are predefined inside Python, that are there, that are either predefined or defined inside a module. All those variables, all that space is called the built-in space, and all the variables in the built-in space are the built-in variables. So after failing to find any variable in the local, enclosing, and global region, it will search for it in the built-in region. So in the built-in region, there is a variable pi. So we have imported it from the math library. So from the built-in region, it found that the value of pi is 3.14. So it accessed that and printed 3.14 and so. Okay. Okay. So this is what the LEGB rule is. Okay. Python will search for a variable first of all in the local region. If it fails to find, then it will go and check in the enclosing region. If it again fails, it will go and search in the global region. If it fails again, it will go and check in the built-in region. And if it fails to find again that in the built-in region also, it will just simply give an error that if there is no variable in either local, enclosing, global, or built-in region. Okay. So this is what the LEGB rule is exactly. All right. All right, Pragya Sapna, these things are clear. The LGB rule is clear to you. Pragya, you're not audible. You may write in the chat box. If it is not clear, just tell me. Like I can explain again, or I'll move forward with few examples. The example is the same which I've explained. Okay, this chapter is. Yes, Sapna, are you there? If you aren't able to understand, it's okay. It's fine. You can tell me, and I can explain again. Okay, Pragya. Okay, Sapna. Thank you. Okay, so this chapter is, I guess, over because it has two part. The Python tutor part, which I had explained in the previous class, this part was over, and the next thing was namespace. The main thing in the namespace was this LGB rule only. That when how this LGB rule tells Python how to access a variable, or where to look for it. Okay. So this LGB rule means local, enclosing, global, and built-in. So whenever Python tries to access a variable, it will first check for it in the local space. If it fails to find it, it will go and check in the enclosing space. If it fails again, it will go and check in the global space. If it again fails, it will go and check in the built-in space. If it finds it there, it's well and good. Otherwise, it will give an error. Okay. So this is what the eligibility rule is. I've given the example. I've given the example. Now the same example is the similar example is also given here. You can I'll share the PPT and you can check it there. I guess I've already shared. You can check it there. And if you couldn't understand, you can ask me. So here are the few conclusion. Python visualizer namespace defines a mapping. That this I've explained. The names. Okay. Local region. LGB rule. Okay. These are few conclusions. Nothing. So everything in this chapter is I've explained. So it's over now, and I will move to the next chapter. The sixth chapter. Let's see what is the sixth chapter. Okay, so the sixth chapter is the strings. Okay, so this sixth chapter, should I start this sixth chapter and this class only, or should I start it in the next class? Whatever you will tell, I will do that. If you can study more, I will explain this. So I'll start this sixth chapter, or I'll start in the next. Start now, sir. Okay, thank you. Okay, Purvi, I'm starting now. Okay, so this chapter is strings. Okay, so a string is what? A string is a sequence of characters represented using single, double, or triple quotes. Okay, it is a sequence of characters represented using either single or double or triple quotes. Okay, so you can define a string like this. So the string's name is message. So the variable names is message, and this variable stores a string, and that string is hello Gita, which is enclosed in enclosed single quotation marks. Okay, and you can use this len function on that string. Okay, on that string variable you can use this len function. What this len function will do, it will it will count the number of characters in that string. It will simply print it. Okay, it will count the number of variables in that string and it will simply print it. So I will execute it. And, where is it? So message is equals to hello Geeta, and I will print. I simply call the length of message. When I run this, सब लेट ज्वाइन कर रहे हैं सेव रन. Okay, I've created this variable message, which is a string hello Geeta, and when I use the len function on this variable message, I'm getting 10. Why I'm getting 10? Because there are 10 characters inside this string. In this string, HEELO 5 characters. This space is the sixth character, and then GITA are the rest of the four. So 6 plus 4, 10 characters are there. That is why the length of this string is 10. That is why when I call the len function with this parameter message, I'm getting 10. So len function finds the length of a variable or a string. Okay. Then there is another concept of indexing of strings. So okay, so our string was hello space Geeta. All right. So this in this string, every character has an index. Every character has an index. HELLO space GIT. Okay, GIT. Okay. So every character has an index. So the very first character will have the index 0. The next character will have the index 1, then 2, then 3, then 4, 5, 6, 7. 8 and 9. So these are the index of these characters. Also, you have these indexes, negative indexes of the characters of a string. So these negative indices start from the extreme right. So from the extreme right, a is there. So this will have index -1. Then the next one will have -2 index. Then -3. Then -4, -5, -6, -7, -8, -9, and -10. Okay. So all the characters of a string have indices. Those indices could are both positive and negative also. So every character of a string will have both a positive and a negative index. So positive indices start from the extreme left, start at 0. So positive indices start from the 0 and extreme left. So the extreme left character will have the index 0, then it will move towards right and increase one by one. So E has index 1, L has index 2, and so on. And all the negative indices is, it is from the extreme right, all the negative indices start. So from the extreme, in the extreme right, we have the character a, which will have index -1. Then we have character 2, which has index -2, and so on up to h, which has index -10. So the set of index of this hello gita, so the set of index of this hello gita is from -10, -9 up to 0, 1, 2, and up to 9. So this is the set of all the valid indices of this string hello gita. Okay. This set contains all the valid indices of this string hello gita. No other index value is there apart from this set for this variable m, which is stores the value hello gita, this string hello gita. Okay. And we can access these characters using these indices only. So so let's say I've created this variable hello gita. So let's say I want to access this. Let's say I want to access this. Let's say I want to access the first character of this message variable. So to access this first character of this message variable, I have to write the index of that character. So the index of h is 0. So I will write 0 here. So when I write 0 and if I run it, I'm getting h. Why I'm getting h? Because I'm accessing the index as the index at the sorry, I'm accessing the character at the 0th index of this string message, this variable message which stores the string hello gita. Okay. Okay. So that is why I'm getting h. Let's say I want to access this character o. So to access this character o, I will write message. And what is the index of this character o? It is 0, 1, 2, 3, and 4. 4. So if I'll write message 4, I'm getting o. Okay. Now let's say I want to access this o only, but with a negative index. I'll write message, and I want to access this character o using a negative index. So what is the negative index of character o? It is -6. Okay. So if I'll write -6 here, again I'll get o only. All right. So I can access every character of a string using either the positive index or the negative index. Okay. Okay. And let's say if I try to access a character at an index that is not present in this string. Let's see what will happen. So we saw that in for this string hello gita, the set of valid indices are -10, -9 up to +9 only. Okay. -10, -9 up to +9. So apart from this indices, these values, there is no other value for the indices of this string hello gita. So if I'll put an index if I try to put a value, so let's say I'm putting 10 here, or let's say I'm putting 11. Okay, yeah. So I'm putting 11 here, 11. We can see that the index 11 is not present in the set of indices of set of valid indices of this string hello Gita. Index 11 is not there. So if I try to access the character at the 11th index of this message variable which stores the string hello Gita, if I will run it, I'll get I'll get an error. That error is called index error, and it is telling that string index is out of range. It is out of this index is out of the range of the valid indices of this string hello Gita, because it stores, because its valid indices are from -10 up to +9. Okay, so this string, this index 11 is not there uh, in this string message. That is why it is giving an error. Let's say I try to access the variable, the index, the character at index 10. So if I run this again, it is giving a string index out of range, because positive 10, the index positive 10 is not present in the is not present in the set of the valid indices of this string hello Geet. -10, -10 is present, but positive 10 is not present. Okay, that is why when I try to access the message with index positive 10, i'll get an I'll get an error. But if I'll try to access again with the negative index, I'll get it. I'm getting h, because at the negative 10th index, because negative 10 index is the valid index of this string hello Gita, and at a at a negative 10, at index negative 10, we have the character h. That is why it is giving h. Okay, okay, this thing is clear, the index concept of this strings. Sapna Pragya and Shiva Ranjani. If anything is not clear, you may ask me, I will explain again, or I'll move forward. So I believe this is enough for this class. I will explain the rest of this chapter string in the next class. Is it fine? Okay. So if the concept of a strings index is not clear to you, you may ask me. I'll explain. Otherwise, okay. I'm getting okay. So okay, that means the concept of string indices is clear to you. So I will explain the rest of the chapter in the next class, in the next lecture. Okay. Okay. All right. So if you have any doubt, you may ask me, or I will, or you may leave the class now. Okay. I'm turning off the screen sharing, and you may leave. Okay, Pragya. Thank you. Okay. You all may leave the class now.